Hello, my name is Paul Drosu, and I'm joined by Jonathan Consoli and Alex Kay to represent the prebiotic organic molecular exploration of Titan's Haze environment and unique surface, also known as the Prometheus team. The Cassini mission shed light on the unique properties of Titan. Thus, Prometheus is dedicated to complete the following goals from NASA's Decadal Survey: explore and understand processes common to Earth that occur on another body, that being Titan, and examine Titan's organic inventory. Prometheus has the following mission statement. The purpose of the Prometheus mission is to investigate the composition and characteristics of the climate, atmosphere, and topological features of Titan. The orbiter will be equipped with the necessary technology to analyze atmospheric composition and properties, as well as perform surface scans to collect data on Titan's evolution and determine the role it plays in the solar system.
Displayed here is our mission's concept of operations. As shown, Prometheus will fly alongside the Dragonfly mission in May of 2021, after which it will perform 4 gravity assists about the inner planets, 3 around Earth and 1 around Venus, which will align the craft for the Titan intercept. At the end of its 9.5-year voyage, the craft will perform an aero capture maneuver and enter its 14-month aerobraking and heat sterilization phase, after which it will spend the remainder of its 34-month mission around Titan gathering atmospheric, magnetometric, and surface data. At the end of its life, Prometheus will descend into the atmosphere of Titan, where if it survives, it will continue gathering visual data, awaiting an eventual recovery or relay link.
The Prometheus mission will start in the second quarter of 2018 with the Pre-Phase A of concept studies. The end of Pre-Phase A will end with a mission concept. It will last 1 quarter. Phase A, the concept and technology development, will last 2 quarters and hold a systems requirements review. Phase B, the preliminary design, will last 3 quarters and will host a preliminary design review. Phase C, the final design and fabrication, will last 2 quarters. It will have a critical design review halfway through and a system integration review at the end. Phase D will be our longest phase yet at 4 quarters. It will contain the operational readiness review, a mission readiness review, and end with launch. Pre-Phase E will last 9 years, and after a post-launch assessment review, we will wait for the Dragonfly to reach Titan. This phase ends with aerobraking on Titan. Phase E, science, will perform data collection over 34 months. Near the end, we will conduct a decommission review and end the mission. Phase F will include a disposal readiness review to finalize the mission.
And now for the spacecraft design. Located on the aft portion of the spacecraft is the Compact High-Resolution Imaging Spectrometer, otherwise known as CRIS. Accompanying CRIS will be the MAP-MAG and MAP-EPS systems, which are both sensitive to magnetic fields generated by electrical components. Therefore, it is imperative that these components are placed on a deployable graphite epoxy matrix boom arm. The internally mounted reaction wheels will be located at the center of mass location in a tetrahedron formation to ensure that all rotations are able to be accounted for. The MMRTG will be mounted on the forward portion of the spacecraft to ensure that the heat dissipation is not in view of other components and will not contribute to their heat absorption. All other instruments will be located in the thermally insulated instrumentation box that is located atop the main chassis and below the MMRTG.
This slide shows the instrumentation that will be carried on board. The Compact High-Resolution Imager, or CRIS, which will obtain scans of Titan's surface features and composition, the JPL submillimeter wave spectrometer, or SMS, which will ascertain data regarding the composition of the atmosphere as well as the dynamics, weather, and climate, the magnetometer and plasma package magnetometer, or MAP-MAG, which will examine the interaction between Saturn's magnetosphere and dipole moment with Titan's ionosphere, and the magnetometer and plasma package energetic particle spectrometer, which will determine the source and nature of energetic particles near Titan.
Upon arrival to Titan, Prometheus will detach from Dragonfly, enter a primary air capture orbit at 361 km altitude, followed by a delta V at the apoapsis of the primary air capture orbit radius of 15,041 km from Titan. This burn will put the spacecraft into orbit with the necessary for aerobraking phase, or orbit for 14.14 months at a constant periapsis altitude of 800 km. The apoapsis will then decrease to an altitude of 1,250 km over nearly 1,200 orbits. Once the spacecraft has reached the required altitude, a delta V2 burn will circularize the orbit in the science altitude of 1,250 kilometers. This mission will utilize a MMRTG, otherwise known as a multi-mission radioisotope thermoelectric generator, which can produce approximately 41.25 watts of energy. Our mission will be broken down into 4 modes: Science Mode 1, Science Mode 2, Downlink, and Eclipse Standby. To account for the heat generated by the MMRTG, the following simulation was formed with the following boundary conditions: 6061 alloy aluminum, 210C on the interior ring to simulate temperature after thermocouple work was performed, a radiative negative 273C applied to the fin area only, 14.82 watts per meter squared, heat flux from the sun, as well as a view factor of 0.2004 applied directly to the fins.
Thank you very much for watching. We will now open the floor to questions.